I'd like to introduce Peter Terry, who's a member of our technical team. Peter has played a pivotal role in the construction and development of this equipment over the past 3 months. The equipment has been pumping heat into the ground for the past 5 days at a COP of approximately 20, and I'd like now Peter to go out and measure the ground temperature about 18 inches below the surface to see what the temperature has risen to. Peter, if you wouldn't mind doing that.
The ground temperature is 34.5 degrees centigrade. We're now going to look at the temperatures going into and coming out of the ground through the evaporating matrix. This is the temperature going into the ground, which is at 23 degrees centigrade. And now the temperature coming back from the evaporating matrix after it's gone through the ground. Coming back at 49.3 degrees centigrade. After we picked up the heat from the ground and put it back into the condensing matrix, we use this water tank here as a supercooler to remove any excess heat from the refrigerant to allow this process to complete. This tank was set at ambient, which is about freezing at the present moment, and over the last 5 years has heated up with the excess heat, which has currently risen to 18.6 degrees centigrade in a 10,000 litre water tank.
By now you would have seen the Theodoma test rig producing a temperature of around 50 degrees centigrade on a cold day in the UK. This heat is extracted from the ground using the cooling engine, which has a COP, as mentioned before, of between 15 and 30. I'm now going to show you how that COP has been derived. In front of you, you can see a pressure enthalpy diagram. This is a plot of pressure on the vertical axis versus enthalpy on the horizontal axis. From the data logger, we've been able to produce what's called a pH diagram, which defines how the thermodynamic cycle works. And I'll just quickly run through that diagram with you. The first point 1 over here is the starting point, where we started just below 0.4 of a bar and the pump takes the pressure up to just around about 7 bar. We evaporate along this line here from 0.2 to 0.3, and then we condense. At the beginning of the 5-day cycle, we were condensing between 0.3 and 0.4, back to 0.5, and then back to 0.1. However, as the system acquired heat, the whole of this graph was moved up, and instead of condensing between points 3 and 4, we were condensing between points 3, 4a, 4b, returning to 2. If one looks at this diagram, you can see enthalpy on the bottom here. Enthalpy is defined as the heat content per unit mass. And you can see that the cycle started at an enthalpy of around about 210 kilojoules per kilogram and finished at around about 445. If we subtract from 445 210, we get an enthalpy change of 235 kilojoules per kilogram. If we go to the formula for COP, which is merely mass flow rate multiplied by enthalpy change divided by power into the pump. The mass flow rate was measured over a long period of time, over 24 hours, as being 0.2 kilograms a second. That multiplied by 235 kilojoules per kilogram and divided by the pump input of 2 kilowatts gives us a COP, in this case, of 23.5. As was mentioned earlier on, COPs of greater than 10 have never been achieved before. Theodoma has, in fact, produced a COP which results in a sea change in the refrigeration industry worldwide. Thank you very much for your attention. Thank you.